Hey guys, sorry to do this again, but this is your Unit 4 Cram Your Skull. I have a meeting this morning and this is the best alternative I know. So, let's get through this, we'll make the best of it. The first thing you got to know is that you have to know the shape of two of your orbitals. The first one is the s orbital, which is of course the lowest, and it's spherical shaped around the nucleus. Okay. The second one you have to know is the p orbital, and it's dumbbell shaped. Okay, so it's dumbbell shaped, one on the x, one on the y, one on the z. Okay, so dumbbell shaped on the x, y, z. While we're talking about that, the next thing you need to know is that each orbital will hold 2 electrons, and the spin number helps tell us that because one spins clockwise, one spins counterclockwise. So each orbital holds 2, one spinning this way, one spinning this way, and that's how they hold 2. When the s and p orbitals of the highest energy level are full, we have a full valence shell. And so that means since the s holds 2, the p holds 6, that 8 valence electrons is a full outer shell. We can also call 8 electrons an octet. Orbitals are a new concept to you versus orbits. Orbits are the old two-dimensional thing you did with Bohr's diagram, and they were basically like the planets orbiting around the sun. Those are orbits. Orbitals is the new, more modern way to look at electron location, and it's the three-dimensional region around the nucleus where those electrons are likely to be located. Okay, with that being said, let's start going through the 3 laws. Okay, there's 3 principles or 3 laws that you have to know. The first one is off-bows principle. Okay, and I try to remember that you bow. Okay, so when I bow, I'm looking down, and all it states is that electrons have to occupy the lowest available energy level. In other words, they'll fill the lowest energy level first before they fill the others. So when I start writing electrons, I have to start at the 1s2. Okay, I can't just jump out and put the first electron in 3p. So off bow, I bow low, says that electrons fill the lowest energy level first. By the way, when all the electrons are at their lowest possible energy level, we say that atom is in its ground state. So if all the electrons are at the lowest energy level possible, that atom is in its ground state. The next principle I want to talk about is, and I'm jumping back and forth here on the sheet to make sure I can find them well, but Hund's rule. And what Hund's rule says is that when I follow along orbitals of equal energy levels, each one of them has to have 1 before any can have a second. So use the p for example, because that's probably the most common. In the p orbitals, right, 2p for example, there are 3 orbitals. Each one has to have 1, and they have to spin the same direction before any of them can have a second. So that's Hund's rule. And then the last rule is Pauli's exclusion principle. And what Pauli's exclusion principle states is that only 1 electron in each atom can have the same 4 quantum numbers. Okay, and I think of this like a basketball team. So I can only have 1 player that has number 1111, and no one else can. It's exclusive to that player. Now the next player could have number 1112, right? And the next one could have 1113, but there's only 1 electron in each atom that can have the same 4 quantum numbers. Let's see. Louis de Broglie. We talked about him a little bit. He came up with this formula, E equals HV. And what he used that for is to determine that that energies corresponded to specific frequencies. Okay, so frequency was directly related to energy, and he used that formula to help him figure out just that thing. Wave frequencies corresponded to specific energies. And again, the energy or energy of a photon, or any way we want to state it, all those things, energy is directly related to frequency. Okay. While we're talking about that, the speed of a wave is equal to the wavelength times frequency. So wavelength times frequency equals the speed of a wave. Therefore, the speed of an electromagnetic wave is constant. So the frequency and the wavelength have to be inverse of each other. As frequency goes up, wavelength has to go down because the speed of an electromagnetic wave is constant. Line spectra. So what electrons are doing is they start out in that ground state, lowest energy level. When we put energy into them, they jump out. They jump to a higher energy level, further from the nuclei. They immediately drop back down, and that's when a line spectra is produced, when they drop back down. A photon of light leaves. When it's going out, it's absorbing energy. It's when it's coming down to the lower energy level that it's actually giving it off. Max Planck proposed that there are very specific amounts that can be radiated, right, or absorbed, and he called those quanta, because the electrons had to jump right to the next energy level and right to the next energy level. It couldn't go in between. It couldn't absorb half of it and it couldn't give off half of it. So Max Planck is the one that said they were small, very specific amounts called quanta. When scientists first started studying that, they used hydrogen, because hydrogen was the simplest element. So they used hydrogen to do it, and they found that hydrogen always produced the same line spectra. And they didn't understand it at first because they thought it would be a continuous spectra, but it made the same line spectra. And the more they studied it, the more they realized that it could only release photons of certain energies. And since it only had one electron, right, it was very, very specific stripes. So hydrogen can only release photons of certain energies. And that is your entire review. That's everything on it. Hopefully you guys test and you do well. Good luck. Sorry I couldn't be there.